This is chapter 8, exam, question 3, part A. For part A, it says, what is the magnitude of the momentum PAI of piece A before the explosion? We are given this. A is 10 kilograms, B is 30 kilograms, A is going to the left, B is going to the right. So for part A, it's asking for the magnitude of momentum. Since before the explosion, the magnitude would be 0 because it's at rest. The A is the point. The A is at rest. That means A is at rest. So the momentum PAI is equal to 0 kilograms per meters per second. Part B is asking, during the explosion, is the magnitude of the force of piece A on piece B greater than, less than, or equal to the magnitude of the force of piece B on piece A? And simply for that, F equal to P over T. And since both pieces have the same magnitude of momentum after the explosion, because they exploded at the same time, so they both are gonna have the same magnitude momentum of the explosion. The forces between the pieces must be equal to each other. So equal to. For part C is asking, the component of the momentum of piece B, P, B, X, F is measured to be positive 500 kilograms per meter per second after the explosion. So for B, P, B, X, F is equal to positive 500 kilograms per meters per second after explosion. Find the component of the momentum PAXF of piece A after the explosion. So we gotta find the momentum of P of part A of A, which would be using PAI plus PBI is equal to PAF plus PBF. And that will give us PAI is the initial momentum, which is 0 kilograms, so it equals PAF, because PAI and PBI, they're both equal to 0 since they're equal to each other. That's in part B just described. Plus PB final, which would then be equal to PAF equals negative PBF. Because we're moving PA, because we're moving PB to the other side to get PAF, so we're minusing PBF, which will be negative. So then PAF is equal to the negative PBF, which we see PBXF is equal to positive 500. So we take the PBF of this, so it'd be negative 500 kilograms per meter per second. And so in the question, they want to find that piece of A. So we isolated piece of A, so PAXF is equal to negative 500 kilograms per meters per second. As you can see, part A is both 0 because it's at rest. There's no momentum for A and B. Part B is actually equal to each other since during the explosion, the magnitude of the force of piece A is equal to each other, because whenever they had an explosion, they both gonna have the same momentum because they're both exploding at the same time. In part C, we just use the formula PAI plus PBI, which is equal to 0 because we could present this at rest, so both of them will be at 0. equal to PAF plus PBF. 0 equals PAF plus PBF minus P, which we then will subtract minus PB to isolate PAF, piece A by itself, which we get piece A equals negative piece B, which was given from the thing in the sentence, which given to us was PB was positive 500. So the opposite of that would be negative 500 kilograms per meter per second.